Now let's practice applying this approach to a few problems. Try this one. Remembering that the index for a square root is a 2, well, 2 goes into 5 twice, so the exponent of k outside will be k squared, with a remainder of 1, so the base of k inside will have an exponent of 1, which we usually don't write. Here's another. This time our index of 2 goes into 6 3 times, so our exponent on the base of a outside will be a cubed, and inside the remainder will be 0. Now recall from the exponent rules that if we have a non-zero base with an exponent of 0, that's really 1. And the square root of 1 is 1. And if our product has a factor of 1, we don't really need to include that. So once we add the exponents here, 1 and 3 is 4, we'll have 2a to the 4th. Try this one. I'm sure you know that the square root of 4 is a 2, but let's take the approach we're working with and think of 4 as 2 squared. Then 2, the index, divides the exponent 2 one time, so there'll be one factor of 2 outside, and no factors of 2 inside. And then 2 divides 7 3 times, so we'll have a k cubed outside, with a single factor of k inside, since the remainder is 1. How about this one? We already have factors of 5 and h squared, and for values inside the radical symbol, I often like to go through and prime factor them. So using our techniques from before, we can see that we can write 8 as 2 cubed. Then 2 goes into 3 once, so we'll have a factor of 2 outside, with a remainder of 1, so we'll have a factor of 2 inside. And then the factor of h will just stay inside the radical symbol. We can still simplify, since 5 times 2 is 10, to 10h squared, square root of 2h. Try the approach on this one. I hope most of you say to yourself, well, square root of 36 is just 6, so I can bring out a 6, and then I'll have a negative 24 when I multiply the factors. But let's take the approach we've been working with and think of 36 as 2 squared times 3 squared. Then the index 2 will go into 2 once, so there'll be one factor of 2 outside. And again, 2 goes into 2 once, so there'll be one factor of 3 outside. And then a third time, 2 goes into 2 once, so there'll be one factor of x outside. Now, it's true that this will leave exponents of 0. But again, all of these will just be factors of 1 under a square root, and the square root of 1 will be 1. So nobody writes this. Instead, they just write the factors that came out, the bases of 2, 3, and x. We don't really need a radical symbol anymore. Instead, we can just multiply the factors and get negative 24x. Here's another. After prime factoring, 50 is 5 squared and a 2. The factor of 2 will stay. For the 5 squared, the index of 2 will go into 2 once, so a factor of 5 will be out. And then 2 will go into 6 3 times, so the y cubed will be out. Again, the factor of 2 that was there originally just is going to stay. And now I can multiply in any order, so 2 and 5 will be 10. And 2 factors of y times 3 more will be 5 factors of y. And here's our last one. 45 prime factors to 3 squared times 5. 2 will go into 2 once, so one factor of 3 will get out. The factor of 5 will just stay here. And then 2 will go into 5 twice with a remainder of 1, so an x squared will get out, and 1 factor of x will remain. To simplify now, I'll multiply 9 and 3 and get 27, and then bases are the same and I'm multiplying so I can add the exponents and get the 5th power of x. Well, that will conclude our work where we've been simplifying some variable radicands.